You may think that it's an easy thing, but in fact, you never know what happens to it when you toss it. Because sometimes it goes like this. Or it may happen this way. And this is gonna be a NeoFS blockchain deport. So some warm-ups or repetitions are unfortunately necessary to do this properly. So let me try it again. And this is gonna be the blockchain department again this time, but before we dive into it, I have a special section for you about the Go language itself. In one of the episodes half a year ago, I have explained how our Go version support policy works, but we have changed it now in August with the release of Go 1.23 for reasons explained in this issue. Basically, we were not synchronized with the rest of the world with our policy that implied that we support some current version of Go and 2 previous. The rest of the world used the policy adopted by Go language authors themselves, which is supporting current version and 1 previous. This created some situations for us where we couldn't update some dependencies, where we had some security issues, for example. They required some newer Go, and Go itself also has become more strict about keeping compatibility with the Go mode version of dependency packages. So we couldn't update because some newer version required newer Go, and we were still using the older one, and this didn't allow us to fix some issues. This was not really appropriate for us, so we have not found any other solution but to change the policy that we have. So far, it looks like the change went smoothly and you can get an updated policy here. And we have also updated all of our libraries and components that we maintain to support Go version 1.22 minimum with the Go version 1.23 as the current one used for production builds. So this subsequently led to a lot of releases of all of these components, and I won't enumerate all of them because there are tens of them. Basically, if you are using anything provided by NeoSPCC and you have not upgraded in the past 2 months, it's good time to do that. I have talked about block fetching from NeoFS previously, and I'm glad to say that we have finalized the storage scheme for that. We also have some plans for improving that in future, but even in its current form, it's absolutely viable and you can synchronize a node from NeoFS using it. So this is going to be a part of the next release expected in October, so then you can try it too. Another really cool feature that I want to tell you about, and that's going to be a part of the next NeoGo release, is coverage metrics collection for contracts written in Go and tested with the NeoTest framework. So this is one of the things that we always wanted to do in NeoSPCC, but we never had time to really dive into. So I'm very glad to say that in fact this is an external contribution that we have accepted. We of course helped in shaping it up and finalizing it and reviewing it and accepting it, but it's a part of a broader community effort that made it possible. So Vyacheslav, Igor, thank you and keep up the good work. The way it works is rather simple. You write your contracts in a regular way, and I'm showing you the NNS contract for example. And you also write your tests in a regular way using the NeoTest framework like we do have here for the NNS contract as well. Then you invoke the standard Go test program and you just specify regular parameters for it to collect the coverage. It ends up, and even though it says that it got a 0% coverage, in fact, you have all of the data in the coverage.txt file already, so you can process it in any standard way. So you can make an HTML report with it. And there you have it. Your coverage for all of the contract files. You can take a look at them and you can analyze them and process them in any way. We've got a number of maintenance tasks queued up for NeoGo, and it will take us some time to go through them, but I hope we are also going to have a bit more resources for doing that next month, because previous 2 months we've made some really good progress with NeoX development, and I don't have any special section for it in this episode, but at the same time I can tell you that the dbft library we have talked about previously is already integrated into the node and it works fine, and we have some really good progress. For more details, of course, follow official announcements as usual. But back to NeoGo, we also want to explore some new possibilities and protocol extensions, like we are currently preparing a proposal for the depends transaction attribute. This is going to be an attribute that would allow one transaction to depend on another. So they will be ordered in a block if they end up in the same block, or one transaction could not go into the next block if the previous one is not already on chain. We also want to push some of the old proposals and especially already accepted proposals that we have made previously, so expect some protocol updates. I have promised you a NeoFS release previously, and we have it delivered with version 0.43.0. It was initially supposed to be fixes only, but in fact we have managed to squeeze in an interesting protocol level change there. Starting from this version, NeoFS can handle EACL rules with targets based on accounts. So previously you could only use public keys there, and currently there is no big difference because the only accounts NeoFS supports are all single key based. But now you can specify EACL rules that don't have keys but rather use accounts. So even though this doesn't change a lot for now, this lays down some foundations for future protocol developments that we expect to deliver in subsequent versions. Anyway, if you're using NeoFS, go grab the latest and greatest. Every NeoFS node needs to store objects received from the network locally in some way. And FS3 in fact is the main subsystem for doing exactly that. As the name implies, it takes objects and puts them into file system tree in some way. The details are not really relevant here, but you can always take a look at how it works at the source code level. So we always knew that this scheme works fine for large objects that are some megabytes, some tens of megabytes in size, but it works not so good for small objects. So we have invented a scheme called Blobovnica some years ago. It was actually the first scheme to deal with the small objects that we had implemented, and it improved performance for small objects, that is kilobyte-sized objects, considerably. It was based on BoltDB databases, and it worked pretty fine, but we had some management issues with it. So about a year ago, we have introduced a replacement for Blobovnica that I have talked about in a previous episode, just about a year ago. That's a lot simpler and actually more performance, since we had gained a bit more experience with it. We have tuned some of the parameters for BoltDB and actually used some better scheme for dealing with transactions. So it worked better than Blobovnica. So Blobovnicas were replaced with Peapod, and we were pretty much satisfied with the performance we got from the Peapod. But in fact, what we also wanted to improve is this middle range. So while we were dealing fine with small objects, kilobyte size or like that, and we were dealing fine with tens of megabytes per objects, the middle range, something like hundreds kilobytes or some small number of megabytes, like 1, 2, something like that, we thought that we could improve that. So we started some testing, we started some optimizations, and we tried different schemes. And after some poking and tweaking, a new scheme was produced for FS3 that was compatible with the original FS3 but had some inner changes. But while we were testing it, we have noticed that in fact it does not improve anything in the middle range with these hundreds of kilobytes or megabytes objects. They work pretty much the same, but in fact it worked faster than Peapod for really small objects, these kilobyte sized and some tens of kilobytes in this range. So we are still doing some testing of it, and we are still maintaining Peapod since it works fine, as we know. But at the same time, the next version is going to provide this updated FS3 that will work faster than the FS3 plus Peapod combination. And we expect this to be more interesting long term, because it allows us to drop Peapods completely in the future if all of our subsequent tests will show that there is no degradation. But at this stage we're still not sure about that, although we also have not seen any test where ppods would somehow magically work better. So this is what we have in the queue already. So with the next release, you could try this updated FS3 and see how it works for you. We have also merged some of the components of the future metadata handling system. Currently, it doesn't change much for existing containers or even for new containers created with the new version of NeoFS, but the main thing is that we are gradually moving forward in this direction too. S3 Gateway went through 3 releases straight. We are linking the latest and greatest one as usual, but actually previous version contained a bit more changes and a bit more updates. We are better with the protocol compatibility now, and actually in fact in part that's thanks to NeoFS node improvements as well, because account-based EASLs work for S3 just fine. And we are also better at security, and we also have improved our performance a bit. We pack objects a bit more efficiently. And we also provide some new configuration possibilities for policy placement management, which is one of the greatest features of NeoFS. So it's important for S3 Gateway to have various ways to specify these placement policies. You can try this gateway on your private networks. REST Gateway was updated with a new version, bringing 2 important changes. First of all, support for Wallet Connect in the new object management APIs that are currently being used by panelfs Neo.org, and also support for range requests. The latter is important when you are dealing with big objects like video files and you want to move forward or skip some part of it, or you want to resume some long-running download if it breaks for some reason and you have some unstable connection. So go grab the latest and greatest as usual. One of the oldest NeoFS demo projects was updated with 4 releases straight. We are linking the latest and greatest one as usual, but actually the 3 latest ones were just fixing some minor things. The main improvement went into the 0.6.0 release that happened on August 30th. And in fact, it changes the implementation language for this project from JavaScript to TypeScript, and also have added an additional page, the About page, that we were missing all of this time for Send.NeoFS Neo.org, because we were always telling people that Send.NeoFS Neo.org is a perfect example of how different NeoFS technologies integrate and interoperate to provide some useful service, but we have never explained this in this detail. So currently we are closing this submission, and you can take a look at this page, see how it works, and explore more things in the source code and make some application of your own that uses NeoFS. panelfs Neo.org was updated to version 0.5.3. No radical changes there, mostly just polishing and fixing minor problems, but at the same time currently we are working on some features for it. We want to provide search capability for it that it currently completely lacks, while NeoFS itself has some really feature-rich search capabilities. So we want to provide this via panel as well. And we also have some ideas on container and object sharing that we are going to explore, and some additional features for node operators like managing verified node attribute domains. Currently you can do this via CLI only, while we think panel can be a better management UI for the same feature. But that's for the future, while currently you can use the latest and greatest version at panelfs Neo.org.